All right, cumulative review, second semester, unit 10. So for 1 through 6, define the terms and use circle C to name them. So a minor arc is an arc less than 180 degrees. So for example, AB. Okay, FE. AF. I can keep going. AE, ED, DF, all right, BD are all less than 180 degrees. Notice 2 letters only for a minor arc. Radius is the line from the center to edge of circle. And I wrote faux instead of. Okay, here's the center. So there's really only, well, there's 3. We have CD, CE, and CA. CD, CE, CA. And those could also be named AC, EC, DC. Okay, those are our 3 options there. A semicircle, 180 degrees. It's half a circle. All right, so that is either this way or this way. Now the blue one we would call ABD. We need that 3rd letter. Notice it has 3 letters for semicircle and a major arc. 3 letters. And we need that one in between. So like think about you're on a road trip from city A to city D and you're going to stop off in B for gas. Okay. The green one I could call AFD or AED. So I'm going from A to D, and I'm going to stop off at F or stop off at E, either way. Okay. A chord. A chord is connecting endpoints on a circle. So for example here, BF. All right. If I drew a line from F to E, or from F to D, or F to A, or E to A, or something like that, E to D, those would all be chords. A major arc is more than 180 degrees and is also going to be using 3 letters. So a major arc has to go past 180. So we might say, you know, A, D, E. Right? Or A, D, F. Or, you know, E, A, D. Something like that. Again, 3 letters. Okay, your starting point, your stopping point, and a stop along the way. Diameter is a chord through the center. Okay, so notice how A and D are endpoints on the circle. AD, right? AD is a line segment connecting points on the edge of a circle that also goes through the center C. All right, converting 240 degrees to radians. When we do to radians, we multiply by pi over 180. And basically we just reduce this. So again, you can use your calculator and you can just type in 240 divided by 180, get a decimal answer, and then hit math, enter twice, 4/3. And you just stick the pi on there. Or you can say 4 pi over 3. Same thing. Okay? Now another way to do that is you can also do alpha y equals and pick the first one and put 240 up here. Arrow down, 180 there. And hit enter. And it will also do it for you. Either way. Convert to radians. Again, we do 30 times pi over 180. Okay? Hopefully you can see that 30 goes into 186 times. So that just ends up being pi over 6. Or you can put it in the calculator and let it do it for you. Now, if we got it in radians, and we want to convert to degrees, then we do 180 over pi. So that the pi's will cancel. And hopefully you see that 6 goes into 180 30 times. And then it's 30 times 11, which is 330 degrees. Okay? If not, you can type in the calculator 11 times 180 divided by 6, enter, get a decimal, and convert it then. Okay. 3 over 2 pi, 180 over pi. Again, the pi's cancel. 2 goes into 180 90 times. 9 times 3 is 27, so 270 degrees. Right, find the length of the arc and the area of the sector. Leave in terms of pi. Okay? So we do the section we have, 150 over 360, and multiply by 2 pi r. So once again, you're just going to type in your calculator, 150 times 2 times 22 divided by 360, and let the calculator reduce it for you. And you'll get 55 over 6 pi, or 55 pi over 6. Now area, same start, 150 over 360, but times pi r squared. So again, on your calculator, 121 times 150 divided by 360, and you will get 605 pi over 12. This is inches, and this is inches squared. Okay? Again, let the calculator help you. All right. So this time we have the big 300 degrees over 360. And remember, we're going to do that twice. Here, we're going to do 2 pi r, and here we're going to do pi r squared. Again, just type in the calculator, 300 times 2 times 6 divided by 360. Let the calculator do the heavy lifting for you, 10 pi kilometers. And then 36 times 300 divided by 360, 30 pi kilometers squared. Easy peasy. Okay, 13. Find the area of the shaded region. Well, if this is 150 degrees here, that means this is 30, and that's what we need. So we do what we just did in the previous problem, but we had to take the extra step of finding the 30 first. All right? And that's going to be pi times the radius, which would be 7. Be careful of that. And when you crunch the numbers and let the calculator reduce it for you, you get 49 pi over 12 centimeters squared. Again, real quickly. 30 times 7 squared, or 49, divided by 360. Get a decimal, hit math, enter, enter. Boom, 49 over 12. All right. This requires you to kind of know how much this is. Okay. This is the white section is 1/4. So 90. So 90, 90, 90, 270. 270, 360 times pi 6 squared. Type in your calculator, 27 pi centimeters squared. That's it. Define and draw a picture of the following terms. Tangent. Okay. It is a line that touches a circle at one point. And only one point. So here you go. That's a horrible circle. And that's a horrible line because it does not even touch. So let's see if I can move it to touch. There we go. And we'll say it touches right there. Okay. And a secant goes through the circle. Like so. Find the measure of the arc or angle. Assume that lines which appear to be tangent are tangent. Okay? This is that simple 2-to-1 ratio. So if this is 120 here, then this is 60 degrees here. Now, the 18 requires a little bit of work. If this is 220, you need to figure out this is 140, and then this is 70. All right, so we're trying to find the big arc here. So remember, it's the big arc minus the small arc divided by 2 equals that. So multiply by 2 on both sides. X minus 48 equals 120. Add 48, 168 degrees. Okay, this time I have the big arc trying to find the small arc. So 198 minus the small arc divided by 2 is 65. Times by 2 on both sides is 130. Okay. I'm going to do a switcheroo here. I'm going to subtract 130 and get 68. Move the x over so it's positive. X equals 68 degrees. See, we're just flying through this. Okay, so in this situation, where they're crossing inside the circle, all we do is 88 plus 58 divided by 2, which is 73 degrees. Now this time, we don't know this. I'm sorry, we do know this. That's 107. We don't know this. So it's 105 plus something divided by 2 equals 107. Multiply both sides by 2, we get 105 plus x equals 214. We subtract 105, x is 109 degrees. Again, at any point you need to hit pause, go ahead and do so. Find the segment length indicated, assume lines that appear tangent are tangent. Okay, so if that's the case, this is a 90-degree angle. Okay, if this is 9, this is 9, this is 15. This is the hypotenuse. So basically it's 9 squared plus b squared equals 15 squared. So 81 plus b squared equals 225. B squared is 144. So b is 12. And that is less than the hypotenuse, so that makes total sense. Same thing here. Okay. This is 6 right here. Okay. Just so you know, we'll need that later. So here's this. So we're trying to find the hypotenuse. We know it's bigger than 6, because 6 is part of it. So it's basically 8 squared plus 6 squared equals c squared. So that's 64 plus 36 equals c squared. That's 100. So c is 10. Well, if this whole thing is 10, that means this here is 4. Okay? So the missing area was 4. The whole side length is 10. Find the segment length indicated. Find OB if AC is 20 and OD is 24. So here we have 24. AC is 20, which means this is 10. So we need to find that right there. Notice that OB and OA are both radius of the circle. So if we find OA, we'll find OB. That is it's Pythagorean. That is the hypotenuse of the triangle. So if we do 10 squared plus 24 squared to get x squared, we get 676. And we square root those, we get 26. So OB is 26, the same as OA. All right, find OD if AC is 30, which means this is 15, and OB, which is the same as OA, is 25. So again, we're trying to find this. 15 squared plus x squared equals 25 squared. That's 225. That's 625. So x squared is 400. And we square root them both. X is 40. So OD is 40. Remember, in this situation, you'll have all these formulas. It's 12 times x equals 14 times 18. So that's 12x equals 252. Divide by 12, x is 21. Same concept here, except we have binomials. So remember, it's 24 times x minus 2 in parentheses. So we don't make the mistake of doing 24x minus 2. That's going to be 24x minus 48 equal to 15 times x plus 4, which is 15x, not plus 4, but plus 60. I'm going to subtract 15x and get 9x. I'm going to add 48 and get 108. When I divide by 9, I get 12. 29 and 30. We're getting there. About halfway through. Find the circumference and area of the following circles. Well, we need to find the diameter here. So that's 8 squared plus 9 squared equals c squared. So c squared is 145. So c is 12.04. That's the diameter, which means the radius is 6.02. Now remember, circumference is the diameter times pi. So 12.04, nope, sorry. It does say rounded nearest 100, so we can't leave it in terms of pi. Well, I'll just put it here. 12.04 pi. So if we type that in our calculator, we get 37.824, which means 37.82 feet. And area is pi r squared. So 6.02 squared is 36.24 pi. So that times pi is 113.85. And that's going to be square feet. Okay, so first we had to find the diameter, and we use the diameter for circumference and then the radius for the area. Just a multi-step problem. Now notice on 30 it says leave in terms of pi. Okay, so we have 30 degrees right here. We have the small side is 10. That means that this side is 20 because that is the hypotenuse. This side is 10 root 3. We don't need that right now, but just good enough practice. Okay, so the diameter is 20, which means 20 pi centimeters. And the area is pi r squared, so 10 squared, which is 100 pi centimeters squared. Okay, assume all these lines are tangent. Quadrilateral ABCD is circumscribed about the circle. If AB is 12, BC is 16, and CD is 10, find AD. So remember, in this situation, opposite sides are equal. Will add up to the same amount. So 10 plus 12 is 22. So 16 plus something should equal 22, and that would be 6. All right, on 32. AB, AC, and BC are tangents. If CH is 4, so that's this right here, which makes this 4, because from a tangent, they're equal segments. It says CA is 15, which makes this 11, which makes this 11. And it says BH is 8, which makes this 8. Find AB. Well, that'd be 11 plus 8, which is 19. All right. Almost there. Second to last page. In circle O, ED is tangent. OF is 10 centimeters. That's right here. Measure of AOB is 20. And measure of GF is 6. That's right here. It's hard to read. AH is 50. BC is 60. Find the missing measurements. Okay, well, HD is a diameter, so 50 plus 20 is 70, plus 60 is 130, so that leaves 50 here. Okay. Also, if you notice, BF is a diameter, so we have a semicircle. So 60 plus 50 is 110, which means this right here, FD, is 70. And we have 70 plus 6, so that means this is 104. Okay. So let's kind of go from there. So AB, If we know AOB is 20, that means AB was 20. So that was 20 right there. BFC. Well, BFC is right here opposite the 60, which means it's half of that, which is 30. CKD. CKD is right here. All right, so on this, there's a lot going on here, and it can get very confusing, so just go slowly and pay attention, okay? So, CKD. CKD is right here, okay? We need to find that, okay? But to get there, we're going to do a little bit of work, okay? So, if you notice, we have a little triangle in here, and this is going to be our key to breaking this down, a few different problems, all right? This angle here is the same as this right here, so that's 70. Also, 50 plus 20 is 70, so this is 70 right there, okay? So, this is 70 degrees right here, okay? Now, this angle right here is going to be half of that 60. So that's 30 right there. That's 100 in that triangle, which makes this 80 and which makes this 80. Okay, so again, you just got to go step by step, take it slow. You got to find pieces of the puzzle, basically. So let me go over that again real quickly. You can always rewind this, but I'll do it one more time. I don't know what's happening here. Well, let me take this off. Never mind. I'll just erase it. Okay. So, we have a triangle right here. This is a central angle that we get from here, 70. Okay. This one down here, we get from half of this angle. So that makes 30. This is a triangle. That means there's 80 degrees here, which means there's 80 degrees here because it's a vertical angle. So CKD is 80 degrees. Okay. Now AEB. Where's AEB? So here's A, here's E, here's B. Okay. What we have here is we have a big arc, a small arc, and this angle right here. Now earlier, we were told that GF here was 6. So we take the big arc minus the small arc and divide by 2. So that's 14 divided by 2, which is 7. So AEB is 7 degrees. All right. ODE. ODE. We've been assuming tangents. So that makes that 90 degrees. Okay. And also it did say at the beginning that ED was a tangent. So HG. I'm trying to find my H. There it is. HG right here. Okay. We already determined that's 104. HOF. So HOF. Okay. Well, we determined that this was 70 degrees before, and this was 70 degrees, which makes these two 110. Okay. DF. Right here. Well, we already determined that's 70. CD. Where's CD? CD is right here. We already determined that's 50 at the beginning. And BED. BED. So there's that subtraction problem again. We take the big arc, 110, minus the small arc, 70, and divide by 2. So that's 40 divided by 2, which is 20. All right. Now let's get into some lengths of CD. So we know CD here is 50. So to find length, we do 50 over 360 times 2 pi r. And we know that r is 10, because we were told that this was 10. Okay. And so when we crunch those numbers, we end up with 8.73 centimeters. Length of HG, similar concept. It's 104 over 360 times 2 pi 10. Put in your calculator, let it crunch it for you. You get 18.15 centimeters. Might be a section you want to kind of go back over and double check. There's a lot going on there. All right, write the equation of circle given the given information. So 913. Okay, well here's the problem that this is off the chart, 913. So I'm actually going to imagine we're going to count by twos. So this is actually going to be a 16 by 16. So 9 would be 2, 4, 6, 8. 2, 4, 6, 8, 10. 9 would be right here halfway. And then 13, this would be 12. 13 would be halfway here. So it'd be right in the middle right there, 913. It's still going to be partially off, but at least you'll be able to see some of it. And the radius is the square root of 26. And square root of 26 is just about 5. It's 5.1. So we're going to go 2, 1. That'd be 5 right there. And 5 right there. 5 right there. And this one's still going to be above, but something like that. If we did 913, maybe somewhere up here, and it'd look like that. So just trying to, whatever works for you. It's not the best one. 2, negative 11, that's not too bad. 2, negative 11, it's going to be 9, 10, 11, about right here. Radius of 3, well, if it's 11, that means it's going to be right here. 1, 2, 3, 1, 2, 3, and then a little bit off the chart right there. There's your circle. Okay, I'm going to do counting by twos again because this is way off. So negative 212. So there's 2, 2, 4, 6, 8, 10, 12. There's negative 212 if I am counting by twos. Okay, and a point on a circle at negative 912. So 2, 4, 6, 8, 9 will be right here. Okay, so that's 2, 4, 5, 6. So 2, 4, 2, 4, 7. So 2, 4, 6, 7, right in the middle there. and then 2, 4, 6, 7 right in the middle there. And this one's going to be off the chart. Something like that. Center, 13, negative 8. I'm going to count by twos again. So center would be 2, 2, 4, 6, 8, 10, 12, 13, kind of in the middle. Negative 8, 2, 4, 2, 4, 6, 8, right there. Point on a circle, 13, negative 5. So again, this is 13, negative 5 would be 2, 4, 5, it'd be in the middle there. So you can see it's 1.5 boxes. So 1.5 boxes there, there, there. Oh, let's see. Check something real quickly, sorry. Oh, and write the equation of the circle underneath. So go back to this one. This would have been x minus 9 squared plus y minus 13 squared equals 26. Because remember, it's radius squared. This one here would have been x minus 2 squared plus y plus 11 squared equals 3 squared is 9. This would be x plus 2 squared plus y minus 12 squared equals, and so we don't know, we have to figure out the distance here. So the nice thing about this one is they both have 12, so it's just the distance from -2 to -9, okay, and that's 7. And if you count here, it's 2, 4, 6, 7. And 7 squared is 49. Now, obviously, if it wasn't straight like that, then you'd have to use distance formula, but we didn't have to there. And since these both have 13, and this is just a distance of 3, that means 9. So x minus 13 squared plus y plus 8 squared equals 9. The radius of 3 squared. Endpoints of the diameter are at 0, 8, and 0, -4. This one actually works. So here's 0, 8. Sorry. 0, 8, and 0, -4. Okay. So the center, 8 plus 4 is 12. So that means divide by 2, radius is 6. 1, 2, 3, 4, 5, 6. There's your radius at 0, 2. Sorry, the center is at 0, 2. And the radius is 6. So that's x squared plus y minus 2 squared equals 36. Endpoints are 5, 2, and -3, 2. Okay, so that's 8. So the radius is 4, 1, 2, 3, 4. So the center is at 1, 2, and the radius is 4. So that's going to be x minus 1 squared plus y minus 2 squared equals 16. And I'm going to finish it 1, 2, 3, 4. 1, 2, 3, 4. There's my circle. And a radius of 6. 1, 2, 3, 4, 5, 6. 6. There's my wonderful circle. All right, last two. Determine whether the point lies in the circle. So we just plug the numbers in. So 1 minus 4 squared plus -16 plus 16 squared equals 3. So this is negative 3 squared plus 0 squared equals 3. 9 equal to 3. Not true, so no. 7 minus 10 squared plus 11 minus 10 squared equals 10. This is negative 3 squared plus 1 squared equal 10. That's 9 plus 1 equals 10. 10 is equal to 10. Check. So that is yes, and we are done.